A function f is defined as an exponential function, and you have to notice that this exponential is a conditional, having conditional here saying x more than equals than 2. So normally exponential, the domain is negative infinity to infinity, which means that this exponential, they're only taking one part only. So for the question A, show that the inverse is exists. So to show that inverse is exists means this function have to show this is 1 to 1 function, only its inverse can exist. To show this 1-to-1 function, we can use algebraic method or graphical method. So for here, I use algebraic method where we're going to substitute x1 and x2. Try to find your x1. So when you have both sides exponential, we can log both sides, or we just compare the power. And you can notice that x1 only having the answer of x2, which means that this function is 1-to-1 function, and you have to answer the question saying that the inverse function is exists. Then you have to find out your f inverse. So by using composite method, f inverse suppose equals to x. So substitute the f inverse into the function. So the x here will be substituted by f inverse. It will be e f inverse minus 2. So we simplify to get out the f inverse. Move the exponential to the right hand side, we get log to the base e, so ln. And then f inverse will be ln. So ln is only for x. Then when we move the 2, we get plus 2. After that, we state the domain and range of the f inverse. So domain for f inverse, we are referring to the range of the function. So the range of the function that we can see here, so our function is taking one part only when we drawing exponential. So domain infinity to infinity, range, when we close this, you can notice that we are getting value of 0, and this exponential is positive, so going up. So our asymptote happen at 0, and going up, shooting to the right hand side because it having the power of x. So from here, you have to be careful, say that your graph only accept from x equals to 2. So means 2 here. When x equals to 2, your coordinate y will be e2 minus 2. So y will be equals to e0. It will be equals to 1. So your point here only happen, your domain of the graph only happen one side only, which is 2 and above. More than 2, 2 and above. So means this side, it never happen. Therefore, your domain of the function should be follow the condition, which is 2 to infinity, and the range of your function, look at your graph here, is no longer 0 to infinity. It will be start from minimum 1, shoot up to infinity. So therefore, come back to your domain f inverse, it will refer to your range. So it will having 1 to infinity. When you want to find your f inverse range, we refer to the domain of the function, which is 2 to infinity. Then continue with that. They say on the same axis, we have to sketch the function and f inverse and state the relationship between these two graphs. So question C, when we want to drawing the function and an inverse function, we need the concept of reflection, where our axis of reflection is happen on y equals to x. So y equals to x will pass through origin. And then we look at the function originally. When your x equals to 2, it is value of 1. So when having your x equals to 2, your value of the function is, when your x equals to 2, when x equals to 2, your coordinate y is equals to 1. When x equals to 2, your coordinate y is equals to 1. So then it will be shoot up. So shoot up. We prolong this reflection axis. So this is our function, original function, starting with 2 and we shoot up. So when you're having reflection, so 2 and 1, original coordinate 2 and 1, when you're having reflection, it will come to 1 and 2. So it will fall at this point, 1 and 2. So this is our F inverse. Make sure you label your point correctly. Inverse functions start with the point of 1 and 2. So enough to have a coordinate stating like this. And then your function point is start with 2 and 1. And then label your x-axis, y-axis, label your reflection axis, and then label your function as F inverse. Then state the relationship between these two graphs. So their relationship is F inverse is a reflection of the graph of fx about the line y equals to x.